Hello to all the COMEDK aspirants out there. How are you all? I hope you all are doing amazing. This is your Ekta ma'am here. So my dear students, what are we going to discuss in this video is the top 15 questions from the chapter Electrochemistry. Yes, the top 15 most important, you can say, the most repeated questions, you can say, that has been asked in the last few years of your COMEDK exam. Okay, so solve with me. Pick up your pen and paper and let's try solving all these questions together. Okay, are you ready? Let's start. The first question on your screen is here. So what will be the standard cell potential of galvanic cell with the following reaction? So here you can see, as you can see here, what is the reaction? We have, okay, so the reaction is the reaction is chromium reacts with cadmium and we get Cr3 positive and cadmium. Okay, so firstly you need to identify which species is getting oxidized, which species is getting reduced, because that will tell us which will be anode and which will be cathode. So as you can say, chromium is getting oxidized to chromium 3 positive. That means the species that is getting oxidized is chromium. Now what gets oxidized, anode or cathode? Yes, correct. That means this is our anode. Anode is chromium. Okay, cadmium 2 positive. Cadmium 2 positive is getting converted into cadmium. Okay, that means it's gaining electrons, and gain of electrons is called reduction. That means reduced species. Which species is getting reduced? Cadmium is getting reduced. Clear? So that means what is this? This is your cathode. This is your cathode. You need to calculate the E0 cell. This whole should go in your head. Okay, you should do it. This calculation in your head. E0 cell will be E0 cathode minus E0 anode. Okay, both the reduction potentials are given. Which is cathode? Cathode will be our cadmium. So for cadmium the value is minus 0.40 volt minus. What is the value for anode? For anode, chromium, the value is minus 0.74 volt, and if I calculate it, the answer will come out to be minus 0.74 plus, okay, this way do calculation, 0.34 volt, which is plus 0.34 volt. The correct answer is option C. If you get the option C, yes, that means you did the correct calculation. Okay, this was just to give you an idea which is anode, which is cathode. Where oxidation happens, that is anode. Where reduction happens, that is cathode. Okay, now let's move on to the next question. Molar conductance of this is the molarity of the solution. Acetic acid is, so molar conductance, this is at any concentration, right? The concentration value is 0.001 m. What is the value of molar conductance? It is 50 ohm inverse centimeter square mole inverse. Okay, the maximum value of molar conductance. So what do we mean by maximum volume? That means this is the value of molar conductance at infinite dilution, right? When you dilute a solution infinitely, that is the maximum value of molar conductance that solution can give us. Okay, so the maximum value means the molar conductance at infinite dilution, that is 250 ohm inverse centimeter square mole inverse. So now my dear students, we need to find the degree of ionization or degree of dissociation, right? Degree of ionization will be equal to what? Alpha is equals to molar conductance at any concentration divided by molar conductance at infinite dilution. Molar conductance at any concentration divided by molar conductance at infinite dilution. What are the values here? Okay, so we have at any concentration, that means at 0.001 m concentration, the value is 50. The value is 50 by, at infinite dilution the value is 250 by 250. So the value comes out roughly around 1 by 5, right? 0.25, but the answer is in percentage. So what we'll do, we'll multiply by 100 and our answer comes out to be 20%. 20%. Did you get 20%? Okay, sorry. Did you get 20%? Okay. So the answer is option C, which is 20%. Okay, let's move on to the next question. If a lead storage battery is charged, then what is the incorrect statement? Firstly, during the charging of lead storage battery, what is the reaction? Lead sulfate, okay, combines with water, what do we get? Lead oxide and sulfuric acid as the product. This is the equation for charging. This is the equation that is happening while charging. Okay, during recharging, okay, this is the equation while charging, then recharging, okay, discharging, the opposite equation happens during discharging. Okay, so in this, from this equation, what we can deduce, the incorrect statement we are looking for, lead oxide dissolves. Is lead oxide dissolving? No, lead oxide is not dissolving. Instead, we are forming, like lead oxide is getting formed in this equation. So, this is the incorrect statement. Sulfuric acid is regenerated. Yes, as you can see, sulfuric acid is generated. Lead sulfate dissolves. Yes, lead sulfate dissolves in water, and this is the equation that is happening here. Density of sulfuric acid increases. Yes, as amount of sulfuric acid increases, its density also increases. So, that means your correct answer is option A. This is the equation while charging, and then again discharging is the opposite. When discharging of battery happens, lead storage battery, this is the opposite equation, like this. Okay. Next question. Okay, the electrodes of a conductivity cell are 3 cm apart and the cross-sectional area. So the length between the electrodes is 3 cm and the area of cross-section is 4 cm square. You need to find the cell constant. Now, cell constant is a very easy one. Cell constant is equals to the length between the electrodes by the distance between the electrodes divided by the area of cross-section. So here, the length is 3 by 4. That will be your cell constant. Obviously, the unit is centimeter inverse. The unit is centimeter inverse. So that means your correct answer is option C, 3 by 4. Next question. The specific conductance of 0.1 m NaCl solution is this specific conductance. What is specific conductance? Kappa is specific conductance. It is equals to 1.06 times 10 raised to power minus 2 ohm inverse centimeter inverse. Okay, its molar conductance is, so we are given the concentration, the molarity is 0.1 m. We need to find the molar conductance. Okay, the molar conductance will be equal to what? Molar conductance will be equal to specific conductance times 1000 divided by molarity. Okay, we are given almost all the values. We are given 1.06 times 10 raised to power minus 2 times 10 raised to power 3, right? And molarity is 10 raised to power minus 1 or 0.1. Okay, if we calculate it, it will come out to be 1.06 times 10 raised to power 2. 1.06 times 10 raised to power 2. That means option A. That means option A. Okay, now let's move on to our next question. How are you able to, are you able to solve all these questions? They are literally simplest calculations, direct formula based. Okay, now this one is actually a nice question. Okay, for this you need some additional data, I believe. Okay, so the E naught value for this reaction is this. E naught cell equals to 0.46 volt. Okay, we need to find the equilibrium constant. Now we know there is a relationship that exists between equilibrium constant and E naught cell. Tell me one thing, which quantity is 0? Yes, E cell is 0 at equilibrium. E cell is normally 0, is always 0 at equilibrium. Why is that? I want to know the answer in the comment section if you do know the reason why E cell is 0 at equilibrium, right? Okay, so tell me in the comment section, I'll be looking for your answers. Okay, so E naught cell is already given. You need to calculate the equilibrium constant. Now the relationship between equilibrium constant and E naught cell. Equilibrium constant and E naught shell is like this. Log of Kc equals to NF E naught cell by 2.303 RT. Now, in how many electrons are involved here? 1 Ag positive needs 1 electron, right? 2 Ag positive means 2 electrons are involved, and copper is converting to copper 2 positive. That means 2 electrons. There is a loss of 2 electrons involved. That means the number of electrons is 2. Okay, so 2 times. Okay, now we know 2.303 RTF, this whole quantity generally we take at standard condition. As we are dealing at standard condition, this is around 0.059. Okay, E naught cell is 0.46, right? We just need the calculation, so one sec. If we calculate it, 2 times 0.46 divided by 0.059, the answer will come out around something 15.3, and the NT logarithm, if we take the NT log of this, then your Kc will be equal to 10 raised to power 15.3. Okay, one sec. 10 raised to power 15.3. So the answer won't be, actually will come in like approximation you will take. So the answer will come around how much? Just a sec. If you calculate it, log table will be provided to you to calculate these values. Okay, your answer will come out around 3.98 times 10 raised to power 15. 3.98 times 10 raised to power 15, which is around 4 times 10 raised to power 15. Kc equals to 4 times 10 raised to power 15. So that is your option C. That is your option C. Okay, so it's coming in close approximation. Okay, sometimes you won't get the exact value, but if this is being used, you will be given the data for calculation. Okay, don't worry. Okay, next question. Calculate again the value of equilibrium constant is being asked. E naught cell is given. Again, tell me why E cell is 0 at when we are dealing with equilibrium. Okay, at equilibrium, why E cell is 0. Okay, now for this again we'll use the same formula. Log Kc will be equals to, this time I know how many electrons are involved. So 4 Br negative are getting converted into Br2, minus 1 to 0. 1 Br will need 1 electron, 4 Br negative will need 4 electrons. So that means the number of electrons involved are 4. Okay, so N, I'm writing straight away E naught cell by 0.059. Let's substitute all the values. 4 times 0.16, as E naught cell is 0.16 volt by 0.059. Okay, so if we calculate it, log Kc will come out closely to log Kc. What will be the value for this one? Okay, so for this one the value will come out around 10.82. Yes, the value will be 10.82, and if we take NT log, which is 10 raised to power 10.82, the value will come out around 6.6 times 10 raised to power 10. So that is similar to 7 something, this one answer, right? 7.03 times 10 raised to power 10. That is your correct answer. Okay, so yes, sometimes you might need a little approximation idea, because if the value is 6.6 something, that means the answer is around this one. Your option, which option is the closest, like closely resembles it? That is your option B. One sec. Okay, yes, calculate the value of equilibrium constant is this. Okay, yep. But if the value log Kc is being asked, if the value of log Kc, then this is your answer. Okay, but we are asked this the value of equilibrium constant, that is Kc. Log Kc will be equal to this one. See, you have the answer almost here. Okay, so don't get confused. Sometimes the examiner wants to trick your brain also. Okay, so yes, don't fall in the tricks. Just read your question, whatever is being asked, calculate up to that point. Okay, let's move on to the next question. Okay, before the next question, a little information for you. So my dear students, we are starting a COMEDK 30-day crash course that is starting from 6th of April. Okay, so if you are from Karnataka or if you're from outside Karnataka, yes, you can apply for these top private engineering colleges in Bangalore, in Karnataka actually. Okay, so we are launching an extensive 30-day crash course where you will be getting complete 11-12 syllabus, class 11-12 syllabus. Whole revision will be done, one shots will be there. You will be covering the whole syllabus, revision, PYQs, everything will be there. You'll be getting 5 full-length mock tests, daily live doubt solving classes. So yes, there will be one teacher assigned to you every day that will take your genuinely doubts, any doubt you have in that particular subject. All your doubts will be handled every day, one doubt solving class. Okay, and plus you will be getting DPPs every day, and your lecture notes will be provided to you so that you don't have to sit down and write your notes. What you can do, you can learn and revise. Okay, And also we have a test series which is COMEDK rank booster test series. It is also starting from 6th of April. So there you will be getting 12 full-length mock test, PDFs with detailed solutions, live solution discussions, and again real-time COMEDK exam environment you will be getting. Okay, so the exam we try to replicate it as close as to the original exam. Okay, so you'll be getting that. So yes, if you're looking for a good test series, this is the one you should go. And if you're looking for a crash course where you can complete everything is totally organized, you don't have to roam around here and there, focus, sit down and just study, so then we have a COMEDK 30-day crash course for you. Okay, both are starting from 6th of April 2026. Okay, now what is the, these were our toppers from the last year, COMEDK 2025. See, so good, so many good rankers are there, right? Triple digits. It's actually a very big accomplishment. Okay, now next question. For this cell reaction, E0 cell is given. If the concentration of C2 positive is ions is double, E0 cell will be. So very simple, very easy question. So E0 cell, you have, what do we have here? E0 cell. Does it depend on the reactant concentration? Does E0 cell depend on the reactant concentration? No, it does not depend on the reactant concentration. What does E0 cell depend on? It depends on the nature of electrolyte, electrodes and solution used. Actually, the nature of electrolyte and solution you use, it depends on that. And second, it also depends on temperature. But other than that, it does not depend on anything else. So it does not depend on the concentration of the reactant. Okay, so even if you double the concentration, E0 cell will be unchanged. E0 cell will be unchanged. Okay, okay. Next question. For this is actually a very nice question. See, we are asked the electrode potential for this whole cell, for this cell, okay, but we are given these values. These three values are given to us. Okay, so let's check what Fe2 positive is getting converted into Fe3 positive. That means it is getting oxidized. Okay, let me write here, this is getting oxidized. Ag positive is getting converted into Ag. That means it is getting reduced. So this is your anode and this is your cathode. E0 cell will be equal to what? E0 anode, sorry, E0 cathode minus E0 anode. What is the cathode here? The cathode is E0 Ag positive to Ag minus E0. What is the anode here? Fe3 positive to Fe2 positive. Fe2 positive. Now let's see, do we have this value? Yes, we do have this value, which is X. Do we have this value? We do not happen to have this value, so we need to determine this value. How do we determine that? So to determine, we need to determine what? E0 Fe, one second, okay, to determine one sec, to determine E0 Fe3 positive to Fe2 positive, Fe3 positive, Fe2 positive. We need to do some calculation. Why? Because firstly, E0 cell is an intensive property, right? And intensive properties are not simply additive. You can't just add or subtract and get the value. Okay, you need to convert them into some sort of extensive property, and from there you will do the calculation. Okay, so here see, for E0, one second. Okay, yeah, one sec actually. Yep, okay, sorry. So for E0 Fe3 positive to Fe2 positive, what is happening here? So we have two reactions. Fe3 positive is adding 3 electrons. Okay, it's getting reduced to Fe. Similarly, let's say Fe2 positive is adding 2 electrons and we are getting Fe. Simple reactions, right? Simple reaction. For this reaction, the value is given. For this reaction, the value is given. Okay, so this is what? I'll calculate it later on. If I subtract these two equations, what will I get? I will get Fe3 positive. Fe3 positive gives, one second, Fe3 positive plus electrons. Fe3 positive plus electron. Plus electron will give Fe2 Fe2 positive, right? Fe3 positive adds 1 electron, we get Fe2 positive. This is the value we need. This is the value we need. Now we know there is a relationship between Gibbs free energy and your cell potential. Gibbs free energy and cell potential are related in what way? Delta G naught equals to minus NF E naught cell, right? So for this equation, let's rewrite the expression. For delta G1, let's say delta G1 naught will be minus how many electrons? N is the number of electrons, right? We have how many electrons here? 3 times F times, what is the value of E naught cell for this reaction? For this reaction, the E naught cell is Z volt. So we'll multiply with Z. Similarly, for this reaction, delta G2 naught will be equal to what? Minus N, number of electrons is 2 times F times, what is the value of E naught cell? Fe2 positive Fe is Y. Okay, remember why are we doing this intensive calculation with delta G naught? Because delta G naught is an extensive property and it is additive in nature, and since it has a relationship with E naught cell, that's how you can calculate it. Okay, so delta G1 naught we have, 2 naught we have. Okay, we subtracted these two equations to get delta G naught 3, delta G3 naught. Okay, that will be equal to minus number of electrons is 1 F NF, and we have times E naught Fe3 positive to Fe2 positive. This is the value we need to find. This is the value we need to find, the final value. Okay, so what will I do? I'll get delta G naught, delta G3 naught is equals to delta G1 minus delta G2. Okay, delta G1 naught minus delta G2 naught. Clear, right? What is the 1 naught? Minus 3FZ. Here I'll write minus 3 is equals to what? Minus F E naught Fe3 positive to Fe2 positive. Okay, this is equals to delta G1 naught, which is minus what? 3FZ minus, then delta G2 naught is minus 2Fy. Now we have Faraday constant in all the in this complete equation, so I'll cancel it and my answer will come out E naught Fe3 positive Fe2 positive will be equal to 3Z minus 2Y. 3Z minus 2y, that is the value that I am looking for. This is the value. If I substitute this value here, I will get my final answer. So for this one, we have the value x, so the answer will be x minus 3z minus 2y. So the answer is x plus 2y minus 3z. Okay, x plus 2y minus 3z. Okay, 1 second. So x plus 2y minus 3g, that is option C. I know it's a bit tricky, yes, and sometimes we keep forgetting that, but you need to know when you're writing the equation, when you're writing the E naught cell for this complete equation, you see that one value is missing, that is the value for this anode. For the anode, we know we do the calculation, right? We know that Fe3 positive adds 3 electrons becomes Fe, the cell potential is given. Okay, similarly Fe2 positive adds 2 electrons, we get Fe, the cell potential is already given. Okay, so I convert them into an extensive property, which is Gibbs free energy. Gibbs free energy for this is minus NFE, this is minus NFE, and if I subtract these two equations, I get the desired equation. That means the E naught cell for Fe3 positive to Fe2 positive. Okay, so I just added these, subtracted these two equations. Okay, and then I just placed the value here. Okay, and from there I got the answer 3Z minus 2Y. That is the value of electrode potential of anode. Okay, so if I substitute it in this final equation, I get x plus 2y minus 3z. Don't get confused. Okay, the values will be given to you. All the values will be given. Okay, you just need to think methodically. So in a method manner you will see. Okay, if you solve it, it won't get confused. You won't get confused. Okay, let's move on to, it was a nice question. Next question, let's move on to that. Again, this is using what? Potash alum. Find the value of equilibrium. This is the equilibrium. Equivalent conductance. Yes, you need to find the value of equivalent conductance. So what is actually This is potash alum, Al2SO4 4.24 H2O. So when normally you dissolve it in water or something, dilute it, it gets converted into this 2K positive plus 2 aluminum 3 positive plus 4 SO4 2 negative. Okay, 4, 5, 6, 7, 8. That means the number of ions involved are, number of atoms involved are 8. Okay, number of ions involved are 8. Okay, so we are given the molar conductance values. Okay, so firstly you should know that there is a relationship between molar conductance and equivalent conductance. What is that relation? Molar conductance. So equivalent conductance at infinite dilution is equals to molar conductance at infinite dilution divided by n factor. What is the n factor here? The number of ions involved is 8. So the n factor we know, we need to calculate this data for potash alum. So how do we calculate? Using Kohlrausch law, right? So the molar conductance at infinite dilution will be the sum of the molar conductance at infinite dilution of the constituent ions, but they have some stoichiometry here, so you multiply them with their respective stoichiometry. So the molar conductance at infinite dilution for your potash alum, I'm just writing it here, potash alum, this is the value I'm looking for, this is the value. Okay, this will be equal to what? 2 times of molar conductance at infinite dilution for K positive plus 2 times of molar conductance at infinite dilution for Al3 positive plus 4 times of molar conductance at infinite dilution for what? SO4 2 negative, SO4 2 negative. Okay, clear? Okay, now we just substitute the values because all these values are given to us, so we'll just add them. 2 times 73.5 plus 2 times, okay, for Al2 it's 189 plus 4 times 160. Okay, so if you calculate it, your value will come out to be around 1165. Yes, 1165 ohm inverse centimeter square mole inverse, that is the value. Okay, now if you substitute this value here, let's substitute it here, 1165 by 8. 1165 by 8. So if you calculate it, if I am right, the answer is 145.625, and the unit is ohm inverse centimeter square equivalent inverse. Okay, so that means option A is your correct answer. Okay, option A is your correct answer. I know you are being asked the equivalent conductance and the value of molar conductance is given, so they have a simple relation. Equivalent conductance is molar conductance divided by the n factor. Okay, so how do you calculate the n factor? N factor is the number of ions involved. In this case we had 8 ions, 2K positive, 2Al3 positive, 4SO4 2 negative, right? So, and how do you calculate the molar conductance at infinite dilution for potash alum? It will be the sum of the molar conductance at infinite dilution for all the constituent ions, okay, times their stoichiometry, how many, in what amount they are present. So 2 times of K positive, 2 times of Al3 positive, 4 times of SO4 2 negative, whatever value we calculated, we substituted it in this equation divided by n factor, which was 8, and that's how we get the answer 145.6 ohm inverse centimeter square equivalent inverse. Okay, they seem, you know, they look a little scary, but they are not, they are very easy. Next question, when a lead storage battery is discharged, so we have the equation for charging. What was the equation? If I remember it correctly, PbSO4 plus H2O will give PbO2 plus H2SO4. This is the equation of charging. What will be the equation for discharging? This will be the equation for discharging. So what is happening in discharging? SO2 is evolved. Correct statement we need to find. Okay, is SO2 getting evolved here? No. Lead sulfate is consumed? No. Lead sulfate is not getting consumed, it is getting formed. Lead is formed? No, lead is getting consumed. These are the reactants now. These are the reactants and this is the product. Sulfuric acid is consumed? Yes, we are adding sulfuric acid in the reactant side. Yes, it is getting consumed, because in the product we are not getting sulfuric acid, we are getting lead sulfate. So the correct statement is sulfuric acid is consumed. Rest all are incorrect. Okay, next question. 1 second. Yes, this is the equation we have. Okay. Next question. During electrolysis of solution of AgNO3, 9650 coulombs of charge is passed through the solution. What will be the mass of silver deposited at cathode? So at cathode what happens? Reduction. That means silver, Ag positive, added 1 electron and it became Ag and deposited at the cathode. We need to find the amount of silver deposited. So the amount of silver deposited will be what? The weight of silver deposited is directly proportional to the amount of charge passed through the solution. That is Faraday's first law, right? So, but we are, okay, one second, but we are not writing it like this. What are we writing it? We write it as normally ZQ. Z is electrochemical equivalent. What is Z equal to? Z is equals to equivalent weight by Faraday, 1 Faraday, okay, times Q. Now the value of Q is given. Q is what? 9650 coulomb. Okay, equivalent weight is molar weight by n factor. Equivalent weight is molar weight by n factor. So for silver, the molar weight is 108 gram, we all know. N factor is 1, as only 1 electron is involved in this equation. So I'll just write it 108 by 1 times 96500, that is the value of Faraday, times 965. So if I calculate it, the answer will be 10.8 gram. 10.8 gram, which is option B. We used what law? Faraday's first law, right? Simple implication that your weight deposited as the electrode is directly proportional to the amount of charge passed through the solution. Okay, so in here it is equal to ZQ. Z is electrochemical equivalent. It is also equal to equivalent weight by F. Equivalent weight is nothing, molar mass by n factor. The n factor is 1 because only 1 electron is getting involved. So 108 by 1 times F Faraday is 96500 and the charge passed is 965 coulomb. If we calculate it, the answer will be 10.8 grams. Okay, next question. Limiting molar conductivity of NABR, Kohlrausch, right? So the limiting molar conductivity of a weak electrolyte is equals to the sum of the limiting molar conductivity of its constituent ions. Okay, so here we are being asked the molar conductivity at infinite dilution for NABR. So that will be equal to what? That will be equal to molar conductance at infinite dilution for what do we have here? NaCl, right? Na, we need Na, that means what do we need? We need Na positive and Br negative. Okay, we'll rewrite it in such a combination that we get the value for NaBr only, plus molar conductance at infinite dilution for Br. Do we have a compound with Br? Yes, KBr. Okay, if we add them, then we have Na positive, Br negative, but we have K positive and Cl negative also. So what we will do? We'll subtract the molar conductance at infinite dilution for KCl, right? So that will give us the correct answer. So NaCl plus KBr minus KCl. That means option B is your correct answer. Option B is your correct answer. Okay? Yes. That is using Kohlrausch law. Kohlrausch, CH. Okay? Law. Okay, let's move on to the next question. 15 questions, yes? Right. How's the Josh? Are you able to answer all the questions? How many questions you did answer correctly? Do tell me, okay? If you want, I can give you the last question as the homework because it's very easy. It uses Kohlrausch law. Okay, so let's start with this question first. We have this reaction, okay, that is happening here. The E0 cell is given. The equilibrium constant we need to find for this reaction. Again, very simple. Log Kc equals to it will be equal to NF E0 cell by 2.303 RT. Okay, now here this thing, because we are talking at E0, these all things are constant standard we are taking, then we'll write simply as N E0 cell by 0.059, okay, log Kc. Okay, now here there is a little variation happening here. So where H2O, H2O positive and OH negative, how many electrons are involved here? So at anode and at cathode, what reactions are happening at anode and what reactions are happening at cathode? So at anode, this half H2 is getting converted into half H positive not half H positive, H positive, sorry, is getting converted into, okay, this is getting converted into H positive and losing one electron, okay. At cathode, this one electron is absorbed by or added to H2O plus electron, and what are we getting here? Half H2 plus OH negative. Half H2 plus 1, 1, 2, yes, half H2 plus OH negative. So how many electrons are involved here? N equals to 1 electrons are involved here, okay. Okay, so this E naught cell that is given here, this E naught cell is negative. This E naught cell is taken negative because this reaction doesn't happen on its own. The auto-ionization of water doesn't happen on its own. You need to provide energy for it. So here the E naught cell is not this one. E naught cell will be minus 0.8277. Okay. Now if you substitute all these values in log Kc, the answer will be 1 times minus 0.8277 by the value 0.059. The value comes out to be minus 14. Log Kc is equals to minus 14. If I take anti-log, the value will be 10 raised to power minus 14. That is the value of equilibrium constant. Okay. Let's move on to the last question. Are you ready? Very easy. You need to calculate the molar conductance at infinite dilution for HOAC, right? All the values are given. KCl, KNO3, HCl, NaOAC, NaCl is also given. Some extra values are also given to confuse you. Okay. So you need to calculate the molar conductance at infinite dilution for HOAC. So what it will be equal to? According to Kohlrausch law, it will be equal to molar conductance at infinite dilution for HCl plus molar conductance at infinite dilution for NaOAC, sodium acetate, minus molar conductance at infinite dilution for, we have HOAC, both the ions we have, NaCl is extra, so minus molar conductance at infinite dilution for NaCl. We substitute all these values, the answer will be, let me just add first, 426.2 plus 91 minus 126.5. So the answer will come out to be 390.7. Yes, the answer is 390.7. Okay, Simon centimeter square mole inverse. Okay, that was it, I think. Yes, thank you so much for watching, and if you have any doubts, do mention them in the comments, and please do answer that why E cell is 0 at equilibrium. At equilibrium, the cell potential is 0. Yes, why? Okay, and take care. See you in the next class. Bye.